For millennia, humanity has looked to a single, solitary moon dominating our night sky. Its presence is so ingrained in our perception of Earth that imagining a different reality feels almost impossible. But what if our planet wasn't so singular? What if, instead of one steady companion, Earth harbored two moons? This seemingly simple alteration could unravel a complex cascade of effects, fundamentally reshaping our world in ways both profound and potentially catastrophic. Today, we investigate the scientific conjectures surrounding such a celestial arrangement, probing its implications for gravity, geology, climate, and life itself. Before we delve into the what if, let's acknowledge the current state. Earth's single moon, while often taken for granted, exerts a colossal influence. It stabilizes our planet's axial tilt, preventing extreme climate swings, and its gravitational pull is the primary driver of ocean tides. According to research published in Nature Geoscience, without our moon, Earth's tilt could vary dramatically, from 0 to 85 degrees, leading to chaotic weather patterns. This celestial dance, perfected over billions of years, is the foundation upon which our stable environment rests. Any disruption could have far-reaching consequences. For our hypothetical scenario, let's introduce a second moon. Scientists often model such situations, and for simplicity, we'll imagine a luna minor, perhaps half the size of our current moon, orbiting Earth at a different altitude and speed. Theoretical astrophysicist Dr. Elena Petrova suggests that a stable two-moon system would likely require specific orbital parameters. One moon would need to be significantly smaller or orbit much further away to prevent immediate gravitational instability, she explains. This delicate balance is key, as any disruption could quickly lead to a collision or ejection of one of the moons from Earth's gravitational grasp. The immediate challenge for a two-moon system is gravitational stability. Researchers at the Institute for Planetary Dynamics have conducted simulations suggesting that the combined gravitational fields would create complex resonances. The interplay between two large celestial bodies in close proximity is inherently chaotic over astronomical timescales, states lead researcher Dr. Kaito Nakamura. Their models indicate that the orbits of both moons would not be perfectly circular or stable, but rather would exhibit oscillations and perturbations, constantly tugging at each other and at Earth. This dynamic environment could mean a perpetual state of minor orbital adjustments. Perhaps the most immediate and visible impact of a second moon would be on Earth's oceans. Tidal forces, already significant due to our single moon, would be dramatically amplified. When both moons align, their combined gravitational pull would create supertides, reaching unprecedented heights. Conversely, when they are at 90-degree angles, the pulls would partially cancel, leading to unusually low tides. A study by the Global Oceanography Institute projects average tidal ranges could increase by 50 to 100%. This would necessitate a complete rethinking of coastal infrastructure, marine ecosystems, and human settlement near the sea, as vast areas would be regularly submerged or exposed. Beyond the oceans, the Earth's solid crust would also feel the strain. The amplified tidal forces wouldn't just affect water, they would also induce solid body tides within the Earth itself. Geologists at the Planetary Seismology Center have theorized that the increased flexing of the Earth's crust could lead to more frequent and intense seismic activity. We could see a significant uptick in earthquakes and volcanic eruptions, particularly in geologically active regions, notes Dr. Anya Sharma. This constant internal stress would make Earth a far more geologically dynamic and dangerous place, impacting infrastructure and human safety globally. The Earth's internal processes, driven by its molten core, could also be affected. The constant flexing and increased gravitational stress from two moons might influence the convection currents within the outer core, which are responsible for generating Earth's magnetic field. While speculative, some planetary scientists, like those at the Geomagnetism Research Group, suggest that a more dynamic tidal environment could either strengthen or weaken the geodynamo. A weaker magnetic field would expose Earth to more solar radiation, while a stronger one might offer greater protection, fundamentally altering our planetary shield. The atmosphere, too, would not be immune. Just as oceans experience tides, so too does the atmosphere, albeit less visibly. With two moons, atmospheric tides would intensify, potentially influencing global weather patterns. Climate modelers at the Institute for Atmospheric Physics suggest this could lead to more extreme weather events, stronger hurricanes, more frequent storms, and unpredictable shifts in jet streams. The energy imparted by the moons could create persistent high-pressure and low-pressure systems in novel ways, explains meteorologist Dr. Chen Wei. This could make long-range weather forecasting significantly more challenging, if not impossible, impacting agriculture and disaster preparedness. The amplified tidal forces would also have a profound impact on ocean currents. These currents are critical drivers of global heat distribution and climate. The Gulf Stream, for instance, helps regulate temperatures across the North Atlantic. Simulations from the Paleoclimate Research Unit suggest that two moons could disrupt these delicate systems, potentially rerouting major currents or altering their strength. Such changes could lead to regional climate shifts, perhaps even triggering localized ice ages or periods of intense warming, notes lead paleoclimatologist Dr. Ingrid Schmidt. This means entire biomes could be displaced or vanish, reshaping global ecosystems. Beyond physical forces, two moons would dramatically alter our visual experience of the night. Lunar eclipses, currently a relatively rare event involving one moon, would become far more frequent and complex. We might witness double eclipses or eclipses of one moon by the other. This intensified celestial light, especially when both moons are full, could lead to significant light pollution from a natural source. Astrobiologist Professor Maya Singh points out, nocturnal animals would need to adapt to much brighter nights, and our understanding of dark adaptation in ecosystems would be entirely different. Human activities, from astronomy to urban lighting, would also need recalibration. The long-term stability of a two-moon system remains a primary concern for astrophysicists. Over astronomical timescales, gravitational interactions between the two moons and Earth could lead to orbital resonances. This is where their orbital periods become simple integer ratios, like 2:1 or 3:2. While some resonances can be stabilizing, many are inherently destabilizing. Researchers at the Orbital Dynamics Laboratory suggest that such resonances could cause the moons to periodically come too close, leading to increased tidal forces or even a collision. Predicting these interactions would require incredibly complex and robust computational models. Given the inherent instability, two primary long-term fates are theorized for a two-moon system: ejection or collision. Planetary dynamicist Dr. Leo Fisher's simulations indicate that one moon could be gravitationally slingshot out of Earth's orbit entirely, becoming a rogue object in the solar system. Alternatively, the moons could eventually collide, resulting in a spectacular, but devastating, impact. The likelihood of a truly stable two-moon system persisting for billions of years, like our current moon, is exceedingly low without extremely specific and unlikely formation conditions, Dr. Fisher asserts. The cosmic clock would be constantly ticking. Another critical factor is the Roche limit. This is the distance within which a celestial body, held together only by its own gravity, will disintegrate due to the tidal forces of another, larger celestial body. If Luna Minor were to drift too close to Earth, or if its orbit became highly eccentric, it could cross this limit. Planetary geophysicists at the Tidal Force Observatory propose that this could lead to the Moon's fragmentation, creating a temporary ring system around Earth, similar to Saturn's. This scenario would dramatically alter the appearance of our sky and pepper Earth with a continuous rain of lunar debris. How would life adapt to such a dynamic Earth? Nocturnal animals, particularly those relying on lunar cycles for hunting or reproduction, would face significant challenges due to variable light and intensified tidal patterns. Marine life, especially in intertidal zones, would constantly be readapting to drastically changing conditions. Evolutionary biologists at the Terrestrial Adaptation Institute suggest that species would either develop incredible resilience or face rapid extinction. The selection pressures would be immense, favoring only the most adaptable organisms, says Dr. Naomi Jenkins, indicating a likely decrease in biodiversity compared to our current Earth. For human civilization, the implications are vast. Navigation by sea and air, currently reliant on predictable tidal and atmospheric patterns, would become far more complex. Cultural and religious practices, often tied to lunar cycles, would undergo fundamental shifts. The increased frequency of natural disasters, supertides, earthquakes, volcanoes, and extreme weather would demand unparalleled global cooperation in disaster mitigation and infrastructure development. Historians and futurists at the Civilization Resilience Forum posit that human societies would be in a constant state of adaptation, potentially fostering rapid technological advancement in fields like disaster engineering and climate control. Even human physiology might be impacted. Our circadian rhythms, which regulate sleep and wake cycles, are subtly influenced by natural light cycles. While artificial light mitigates some of this, persistent, brighter nights from two moons could potentially disrupt these rhythms. Medical researchers at the Chronobiology Studies Group suggest that sleep disorders might become more prevalent. Furthermore, some studies indicate a correlation between lunar phases and human behavior, though this remains a contested area. With two moons, any such subtle influences could be amplified, leading to a new level of biological and behavioral complexity for humanity. So, what if Earth had two moons? The evidence, compiled from various scientific models and theoretical conjectures, paints a picture of a planet dramatically different from our own. It would be a world of heightened geological activity, supertides, and volatile weather. The night sky would be a celestial spectacle, but also a source of constant challenge. Life would be under immense pressure to adapt, with biodiversity potentially reduced, yet new, highly resilient forms emerging. Human civilization would be defined by its ceaseless struggle against and adaptation to powerful natural forces, pushing the boundaries of engineering and societal resilience. Despite the extreme conditions, most scientists agree that life, in some form, could still emerge and thrive on a two-moon Earth. Extremophiles, organisms that flourish in harsh environments, already exist on our planet. The question is not if life could exist, but what kind of life? Astrobiologists like Dr. Amelia Vance suggest that initial life might develop in sheltered deep-sea vents, less susceptible to surface chaos, before slowly diversifying and adapting to the dynamic surface world. It would be a testament to life's incredible tenacity and adaptability, she concludes, highlighting the persistent drive for existence even in the face of profound planetary challenges. The hypothetical scenario of Earth with two moons offers a fascinating glimpse into the delicate cosmic dance that shapes planetary environments. It underscores the profound influence of celestial mechanics on every aspect of a world, from its geological heart to the patterns of life on its surface. While our own Earth enjoys a singular, relatively stable lunar companion, this investigation reveals that even a minor alteration in our cosmic neighborhood could initiate a cascade of dramatic transformations. It's a powerful reminder of Earth's unique position and the intricate balance that allows life to flourish in our familiar night sky, under the gaze of a single, steadfast moon.